Okay, this is on electrostatics, right? Current of just electrostatic. Now we have two small uncharged. This is important because that means it tells us that it is at first neutral. Okay, I do have some students who always don't read the first statement. They read the first statement, it tells you important information and that they are metal. So it means metal, they are good conductors. That means they will have C of electrons, right, that are free to move around. So A and B, they are suspended side by side using insulating thread. That means the electrons cannot flow through these threads. That means they are, if I don't have any channel for the electrons to move about, they are bounded inside the sphere. You all get the idea? Sometimes they don't use insulating thread. They use things like insulating stands. It's the same purpose. Alright. So now rod X is positively charged. They are both conductors. X and Y are both conductors. They are held using insulators. That means instead of holding it with my bare hands, I have an insulator in between my hands and the rod X and Y. That means electrons cannot flow in and out. They are stuck there, just like your insulating thread. You all get the idea? Rod X is positively charged. This is shown on the diagram as well. It touches sphere A. Rod Y touches sphere B. Now, when rod X touches sphere A initially is neutral, right? So what will happen to A? What will happen to the electrons in A? The electrons will move in, right? Because this is positively charged, and the key concept here is unlike charges attract. Unlike charges attract. So electrons that are previously in A, they will move somewhat to rod X. Okay? So now, overall this system of X and A, what is the overall charge? The overall charge will be positive. Why neutral? Why negative? You think about it. This guy is positive. This guy is neutral. That means maybe I give it a value of 0. I give this guy a value of plus 100. They come together. Now I have two bodies. What is their overall value? 100. Agree? But on the other hand, if I have a negatively charged sphere touching a neutral, so overall they will be negative. Does it make sense? Right. So together X and A, they will be positive. Okay? Now I split them. Electrons don't know that I split them. You're like, huh? Right. Overall is positive. So now X will be, if I split them, X will be what charge? Positive. A will be positive. Okay, after they split, as a system, they together collectively they are positively charged. After we split them, they are still individually positively charged. And therefore, A must be positively charged. So why is A keeping a distance away from B? Because B must be positively charged. And I heard somebody say poles. Poles is used in magnets. Once you write poles, 1 mark will be deducted. So B must then be positively charged because like charges repel. Is it, do you all need to write this concept? Do you all need to write this concept of like charges attract and unlike charges attract and like charges repel? You have to write it because that's the science concept here. Okay? So in your answer, have to be very explicit. You will see this written in my set of notes. Alright. So say I explain what can be deduced about rod X. Let's look at the answer. Okay, what is observed is that rod Y is positively charged. Just by writing this, you get your 1 mark. When rod X touches sphere A, this is important. Electrons from A are attracted to X. They will move inside. And this is a science concept that you need. The unlike charges attract. So it moves in. This results in sphere A being positively charged. And since A and B repel each other, they both must be positively charged. Does the explanation make sense? Are you able to write this? If not, memorize some of the key terms, look at my notes, adapt and change according to the context. Okay? Are these answers available in your Okay. It's different Okay, so I may upload all these answers. Okay, I'll upload all these answers. Then your mark. And can I go to the next question? I will upload all these answers. Okay, this one. How are the resistors connected? Series. Then this is parallel. That means across here is going to be 12 volts. Across here is going to be 12 volts. Alright. Now the combined resistance of all the resistors in the circuit. So we can actually do this first. Do you all know how I get my 10 ohms? Because very simple, they are all connected in series on this line. So you just add them up. Then after that, we do our parallel resistors. Remember this formula. I want to catch those people who didn't flip. Anyone who didn't flip. 1 over IFF equals to 16 over 60, correct? So anyone leave your answer as 16 over 60? I hope not. So always remember to flip. So you'll get a certain value. Okay, can? Let's look at the answer. You should get 3.75. Okay, this one is quite a shortcut, right? But it's 8 plus 2 series. Then this is parallel to this. So 1 over 10 plus 1 over 6. Then they do the flipping by using indices. Okay, must be able to get. Yes. Now, the next question. The current in the resistor of resistance 8 ohm. 8 ohm. So this one is a bit tough. I'm looking at this current that's flowing through here. But I know that this 8 ohm is actually found in this 10 ohm. And I know that this is the total resistance in the upper branch. And it's going to have a 12 volt potential difference. Therefore, the current will then be 12 divided by resistance equals to 1.2 ampere. Were you all able to get this value? The tutorials, the workbook questions on DC circuit are tougher than O level. O level you must score. Okay, O level you must score. So we get 1.2 ampere. And now they want the power dissipated in the resistor of resistance 6 ohm. This is sometimes students miss out. They just P equals IV. Whatever I they can find, whatever V they can find, they just whack. But they want specifically the power dissipated. So P equals IV. This is unknown. What is the current flowing through the 6 ohm? Do y'all know? 2 ampere. Look at this. 6 ohm is here. Potential difference across it is 12 volts. 12 divided by 6 ohm, we get 2 ampere. What's the voltage across it? 12. So the power is 24 watts. V square over also you get the same value. Okay, so quite simple but later when you do until 21, 22, 23 its difficulty slightly increased, but still the same concept. Okay, let's move on. The charge, what letter is charge? Q. Somebody still tell me C. C is a unit for charge, coulombs. Through the battery in 10 minutes. This is a trick here. In order to use Q equals to IT, your T must be in SI unit. So it is 10 times 60, so it's 600. So don't lose this kind of marks. They want through the battery. You see how yesterday I warned you about O level, right? Just now it is through for this 6 ohm. So you think that, oh, is the current going to be used here? But they want through the battery. So you need to find the current through the battery. That means what is the current that comes out from the battery? Remember we had this circuit whereby the IFF just now is how much? 3.75 So actually I can convert this circuit to 3.75. Yes? And the is 12 volts. So I can find the total current that comes out from the battery. Okay or not? But did I find something like that already? 1.2 ampere plus what is the current through the 6 ohm? 2 ampere, right? So what's the total current that comes out from the battery? Must be some, right? So it's 3.2. Okay? So the current is 3.2. Sorry, I jump here, jump there, but you all understand how I get 3.2 for current? Can So even if I use this simplified circuit, my current that comes out should also be 3.2 ampere. So actually DC circuit is not difficult. The difficulty comes from the question jumping here and there. Sometimes they want 6 ohm, sometimes they want 8 ohm, sometimes they want current coming out from battery. So you have to read the questions very carefully. So 3.2 multiplied by 600, then I will get a value of, never captured. So when a current flows, it produces a magnetic field. When placed in an external magnetic field, which is my north and south, right, there will then be a force. Then there will be a force by using Fleming left-hand rule. Okay, so first step is, this is plus, if you don't know, this is minus. Current always comes out from plus and goes back to the negative. So still remember your Fleming left hand, middle finger represents current. So let's do the field first. External magnetic field is going from north to south. Yes? So current is this way. Magnetic field is this way. So the force is vertically downwards. But this is 3D diagram, a little bit difficult. Can we try converting it to 2D? North and south. This is AB, this is CD. For AB, what is the, if I look here, if my eyes is looking here, what is the direction of the current that is entering or leaving AB? What's the direction? Into, so it should be a cross, then here should be a dot. Then isn't it simpler? Can see my current is falling into the cross, going into. My north to south is the external magnetic field shown by my first finger. So my thumb will be pointing vertically downwards. Need me to explain again? Okay, so this is my force on AB, this is my force on CD. So draw an arrow on side BC of the coil to show the direction of the conventional current. So this will get you your 1 mark. They are scaffolding it. They want an arrow to show conventional current. Oh yeah, I never read. I never read. Will that happen to you in O level? On the side on side BC. not on the side. Not on the side of BC. I still want you to draw on the wire itself, on the wire, okay? Because current flows in the wire. So draw arrows on side AB and CD to show the direction of the force. So AB, CD. Why didn't they ask us to draw the current on AB? Why? If they ask you to draw the current on AB, will it be easier? Sorry, today I'm a bit off. I'm really a bit off today. Okay. So if they ask you to draw on side AB, will it be easier? So alright, but they purposely ask us to draw on the side BC. I don't know, to me they are trying to pull a fast one. Maybe then you draw BC, you do like that. For BC, you do like that. You wouldn't think of drawing your current this way. I think they are trying to pull a fast one. Do you think they can ask next time? Why does it turn? Why does it turn? Or what is the missing component to make it turn continuously? It is the carbon brush and also split ring, right? And you can expect these questions to come out in the next few papers. It will still turn, but it will not turn fully. It will not turn fully. So I think subsequent paper, or at least in the pure physics paper, I do see questions whereby why doesn't the coil turn 360? Why doesn't the coil turn 360? There are questions that are asked like that. Okay? That is why we need split ring. So as to reverse, what's the function of the split ring? They will ask you for function. This one, why does it turn? Is it why does it turn? They may give you an additional 2 marks because they already give you marks to identify the forces. Then they may give you additional 2 marks. Then you have to talk about moments. Then they can ask you for what is the missing component, carbon brush, what's the function to maintain continuous contact. Okay, all this can be found in my notes. They can ask you for the function of the split ring. All right. Okay, a rocket that can launch a satellite to study other planets is shown. So actually, first statement, nothing much. Stage 1 carries a fuel to take it above Earth's atmosphere at a height of 67 km. So this is the height above the Earth's surface. Stage 1 has no more fuel. That means the mass becomes lesser or even 0. And then it detaches from the rest. At this height, stage 1 has a mass of 1.3. That means the empty body has a mass of 1.3 times 10 to the power of 5 kg and a speed of 2.3 km per second, which means this is 2,300 meter per second. Calculate the KE. KE is, remember I told you all made a mistake in your prelim, half m square b, half mb. It should be half mb squared. And so I substitute everything in 1.3 times 10 to the power of 5. And my V I need to change to SI unit because KE is a SI unit chapter. MGH SI unit formula. Work done SI unit formula. Okay. So this will be 2300. Do not forget the square. Let's look at the answers. I'm sure they'll talk about. No need. No need standard form. But how many zeros will you have? Should have, no, 9 zeros. So make sure you want to write all your zeros. You transfer your zero accurately. Okay? Okay, then let's go back to part B of the question. After stage 1 detaches, it continues to rise. As stage 1 rises, its speed decreases. Why does the speed of stage 1 decreases? Let's look at the answer. So it detaches already. Is there any more force that's acting on it? Initially, the rocket is flying up or down? Upright. Rocket always fly up, cannot go down. Into the soil, cannot. So the rocket goes up. So after this is detached, the rocket say bye-bye already. After this is detached, will it continue to go up or will straight away fall down? It will continue to go up because it was already moving in that direction, right? Yes. Okay. Can. Yes. So this is stage 1. So it will continue to go up. But at this point whereby there's no more rocket power, it's on its own, what is the force acting on it? Gravity. Gravitational force is still pulling it down. Is there air resistance? It has at a height above the Earth's atmosphere. Earth's atmosphere, the background knowledge is that it is due to the air around it. So when it's above the Earth's atmosphere, somewhere here, there is no air resistance. That's why we cannot talk about air resistance. But is Earth still exerting a force on it? Yes. But is the gravitational force as strong as when it's on Earth? No, because as we move further away from the object, the gravitational force gets smaller and smaller. Just that there's no air resistance and the gravitational force that Earth exerts on it is getting lesser and lesser. Just like now, y'all are very near to me. I have a force on y'all. But once y'all go home, y'all start to do your paper 1 already. Example. Okay, let's see. There is a resultant force due to the weight acting downwards on stage 1. You need to identify that there's the force that's acting on it and only this force of weight. Now, since resultant force acts opposite to the direction of the motion, what is the direction of the force that the Earth exerts on it? Downwards. But when it just detaches, it was still going upwards. Correct? So the resultant force is opposite to the direction of motion. So it experiences deceleration and speed decreases. I'm going to draw a free body diagram here. If you are moving this way and I push you from behind, will you move faster or slower? Faster, right? If you are going in this direction and I exert a force in the opposite direction, I'm pulling you back. Can you go faster? You will go slower. So draw your free body diagram with the motion there and you reason to yourself, I have a force that is opposite to my direction of motion. So I will definitely slow down. Okay? So first mark is to identify the force. Secondly, the force is opposite to the direction of motion, therefore experience deceleration. Okay, why is air resistance wrong? Why is this statement wrong? There is no air resistance at all. So you cannot write about air resistance. You cannot write that no more fuel because there's actually no more fuel. Stage 1 then falls back to Earth. It shows how its vertical speed changes as it falls. So what is important about VT graph? Gradient represents acceleration and distance, area under the graph represents distance. So even before you read the question, you see VT graph, please write all this down to remind you that these are possible questions that they will ask. Now, the force due to friction on an object falling in air resistance increases as the object speed increases. That means as speed increases, okay, air resistance will increase, right? Girls with long hair, when you walk, your hair don't fly backwards, but when you run, the hair will move backwards because your speed is faster, the air resistance is higher, correct? So describe how the acceleration, that means we need to describe the gradient, how it varies as it falls towards Earth with reference to forces. A lot of things that you need to take note. Firstly, you need to describe the acceleration. And what is acceleration represented by? By the gradient. But you need to explain with reference to the forces. With reference to the forces acting on the object. Okay, to explain these variations. So initially, is the gradient steep or gentle? It is steep. Compared to here, it is gentle. What is the gradient here? Is it gentlest? It is 0. Right? And since gradient represents acceleration, that means the acceleration here is the highest. The acceleration here decreases. I want to ask you this. If the acceleration decreases, what is the speed? Is it increasing or decreasing? Is it decelerating if the acceleration decreases? No, the speed is still increasing at a decreasing rate. You see, the more you practice, the more you understand this. I think about some things. So the curve part, at first it falls with decreasing acceleration. Okay? With increasing speed, the air resistance increases. So they lump up the, just now my steep and gentle together. They lump it up to be a decreasing acceleration. They lump this part. Right? It was steep to gentle, so this is decreasing gradient. Therefore, it is decreasing acceleration. They lump up. Just now I say steep then gentle, right? I separate them, but they lump it together. It falls with decreasing acceleration. With increasing speed, air resistance increases. This was given in the question, so this don't get you your 1 mark. But it tells us about the air resistance. Since resultant force equals to weight minus air resistance, and weight is constant, so the resultant force decreases as air resistance increases. So yesterday I think I told you all, it is good to always write down the formula. Use formula to explain. So in this case, we use Fnet formula, right? So this decreasing resultant force results in lower acceleration because Fnet equals ma. Quote the formula. Second part is the distinct flat line. Is flat line, Then the acceleration decreases till it becomes 0. No more acceleration. So with further increase in speed, air resistance increase till it is equal but opposite to weight. So now the forces are balanced and your resultant force is 0. There is no more resultant force and this thing actually moves with terminal velocity. In O level, are you able to write like that? You must explain in terms of forces. That's why I recommend you reading this question again. Okay? It applies to many situations. Yes. Okay, I'll upload all the answers. Okay, then you all can look at it. I'll upload the answers. Okay, state the energy transfer, not conversion. This one was way back 2016. That occurs as stage 1 force at constant speed. What is important here? Constant speed. Okay, that means the gravitational potential energy changes to thermal and sound energy. Remember, the object was still falling down. So the energy from the gravitational potential store is transferred to thermal and sound energy or internal energy of the surrounding, but not to the energy in the kinetic store because the speed is constant.